So, okay, good. So what's the question again? Okay, lesson library is the one CF here. So in line 12, so here you set license as dash LASNAN. Can you see this command? So it specifies the address sanitizer library. So I will explain in later slides about how we're going to use this. And so yeah, so on the other hand, if we specify the build type as release, then the LSN library is empty. So we don't use that library when we are building a release version of our code. So Frank, have you done all this? Done with this
Yeah.
shell script?
Yeah, I finished this part.
Then for the build shell script, build debug and the build release, you type in this CMake dash build, so double dash, then build underscore debug for this debug and for this debug shell script, and build a release for release shell script.
Mm-hmm. Okay.
So, yeah, so here is an example. You can just view the example I provided over here. It's one line. It's CMake dash build and build. And for the config file, just put CMake dash s, and then there's a period here, and dash e build the debug, and the dash d, and the CMake build type equals to debug.
Yeah. Yeah.
What is the difference between dash build and dash b build?
So the first command here specify all the build the folder. So what I mean here is that so here is an explanation. So when you type a CMake dash s, it specify a path to a source. So basically from the current folder of your CMake list file. And the dash b, it will specify the path to build. So it will put all the build stuff and the generated make files in this this folder, and then it will add this CMake type variable in your build system. So when you execute the dash build, it will actually execute the generated make file in this folder, and then produce all the executables and the libraries. So this one is to configure your workspace, configure the entire build system. This command is to actually build your executables. Is that clear?
Yes, thank you.
Oh, yes. So these are the commands for CMake. If you are using hacking projects for ROS, you can just use this link to see how to change this CMake build type in this hacking context. Okay, all done?
I'm done.
Okay, so the next, so what about you, Shamini?
Yeah.
Okay, so the next thing is, so I hope you have this folder here. So let's go to time. Open this terminal by this and in terminal, type and we'll show all the directories and the files. So what is color? Okay. Okay. So then you just open the you can open your VS Code and use this prompt menu to open up a new terminal and type LL double L to show all the files and directories you just created. And if it is green, then you can execute your shell script. If it is gray, then you cannot execute. You have to specify the permission to your shell script. So right now, everybody just type LL and see what is the color of your shell script. Is it green or it's gray?
They're all gray for me.
Me too.
Gray, okay. So what about you, Cindy?
I already gave them.
Okay, yeah, you get the gave them the permission. Okay. Okay, so if it's gray, just using this command. So sudo chmod, and this is plus x. Plus x means add permission to all users, and this is then followed by the name of your shell script. So just add this execute permission to all the shell scripts, to all these 4 shell scripts you just created, and then run LL again to see if all these files turn green.
It's all green.
Okay, done.
Okay,
And
good. About
they're all
Shiny?
green now.
Good. Okay, so now we can finally execute this shell script. So you can just run this debug. So debug.sh shell script first. You run this debug shell script and you run this release.sh shell script and followed by build, and see if you can build this see if you can build your source file. So everybody get your source file compiled.
I have.
You have any issues or problems? Okay, Cindy, if you have a issue, you can just show the screen to us. Yeah, let's see what happened. Okay.
I'm having some trouble as
Yeah.
well.
If you just try again and see if you can share. Okay, I will stop my okay, then you can do it. I cannot load cache. Yeah, okay, you need to run config shells with first. Have you run it first?
Yeah.
And then, yeah, okay, close out. Okay. Can you run the build? Let me see your config release config release file. Config release.sh. Right. Yeah. Oh yeah, type rerun. So it's -b followed by build release. See you are specifying the no the -b followed by build release, not debug. And check if you type all other stuff correctly. So what about you, Frank? Have you compiled for the source file?
Let me show you my screen.
Okay.
Okay, so command is build release or is it build config? I mean, either way.
Yeah. So you need to run config debug and the config release.sh before you run the build.
Okay.
So what okay, let me see your config debug.sh -s. Yeah, just run this config debug.sh. See whether
Okay.
we will load the build system.
Do you
This
see this?
working directory. Does not. Yeah, you mistyped the CMake list. So the CMake list, the L in the list should be capitalized.
Oh, okay.
Yeah, and try that again. Try the config starts with before the build. Okay, yeah, CMake minimum required. There is an underscore, line 1.
Oh, yes.
No, the post. in all of the words, yeah, connecting all of the words. Okay. So if they are green, no, CMake minimum, and there's an underscore between minimum and required. Yeah. So if the command is green, it's blue, it should be okay. If it's white, it might be a problem.
Okay.
And yeah, run again, see if it works. Okay, now it works. And then run
config
the complete
release. Right?
underscore release. Okay, let's see, works. Good. And then run build. I got okay. Oh, there is yeah. So you type the source code around. So go to your source code, and okay, can you open my oh yeah. So you type this around. Oh, can you open my lecture slides? I think you have.
Oh, this.
Yeah. So
I think I found what the issue.
Good.
Yeah, I saw that. I knew what the typo was.
And release. So anybody else has any problems in terms of building? Hold on.
Okay, thank you.
Good. Good.
Yeah.
Okay. Okay, since we now have a working example, now I will just show you how to execute the program you just built. So as we specify these two folders here, you will then see there are many stuff inside this folder. So the make file here, you should see a make file here. This make file is actually what generates your code. So as I mentioned in previous slides, the CMake list is only a build system generator. So what does it mean is that it generates this make file, and when you see this make file, it's very abstract, right? So you can see some commands and those things, but it is more complicated and more abstract than the CMake language we just used here. So this is more like close to a high-level programming language, and this one is like a very low-level language for build system. So this is one of the reasons I recommend you to use CMake rather than directly writing the CMake file by yourself. Okay, so in the terminal, you can navigate to the build folder. Navigate to the, for example, the debug folder, and type LL. Then you will see the program you just generated. So here I have 4, but for your example, you should have only 1, named test 1. So then in this terminal, you can just type period and test 1 to execute the program. And then you should see 10 numbers printing out in the terminal. Can you see all the results? What about Chao? What about it? We're finished. Okay. So everybody knows how to execute this program.
Yep.
Good. Okay.
I have a question.
Yes.
Why do we run it from build debug and not from SRC?
So what? Pardon. What's the question again?
Why do you run the test file, the test 1, from build debug and not from SRC?
The SRC contains your source file. You cannot run your source file. The only stuff you can run is the actual binary executable file generated by this source file, right?
Okay, I see.
That is how compilation works. So it compiles your source file, and then it will put the result of the compile here, and so that you can execute your program. So this test one
Okay.
is actually the program that can be run, and this is only a source file for the compiler to work with. Is that clear?
Okay, I see. Thank you.
Good. Okay, then now we move to a little bit more complicated example. So this example is a little bit complicated. If you think the typing is uh, a little bit laborious, you can just directly copy the code from my repository. Yeah. So basically, what we are trying to do here is that we set up a vector, the container, and we'll put random numbers, so uniform distributed random numbers, into this container, and we'll use a sort algorithm provided by the C++ STL to sort the random number from the greatest to the smallest. And finally, we will measure the time. So we use the chrono library to measure the time it takes for this sorting algorithm to work. The purpose of doing this example is that we will compare the performance of our program on the different compile flags. So remember we have a release mode and a debug mode, right? And then in the release and the debug mode, we set the compile flags to be -00, while in the release version, the compile flags is -03. So there are different levels of optimization. Now this example will show you the performance of performance difference based on those your choice of compilation flags.
Longhao, do we need to run the config shell again, or we can directly build it?
No, in this case, you don't need to run the config again. You can directly run the build.
Okay, got it. Thanks.
No, no. Yeah, so the order is not fixed, and run release first. Debug is totally fine. So all done, or you still still need some time?
I have done, and it shows that using release version is 10 times faster than the debug version.
So what about you, Cindy? Have you had any results yet? Have you done? Have you done typing all this code? Oh yeah. So the first thing is to type the code and see if you can compile. Is that done? Okay. So then run the binary file generates. So basically run your program. So it generates a debug version and a release version in the build debug and the build release folders, and then you run the program, the debug program and release program, and it will show you how many nanoseconds had passed for sorting. Okay, for sorting this series of numbers, and then finally just use a calculator. So record your results, use a calculator to calculate the speed difference between this same program, but compiled in different flags, and see what is actually the difference, the ratio between using compile flags and without compile flags. So Frank, can you calculate a ratio between that? So using a calculator? About 10 times, right? So everybody get similar results?
Yeah, it's about 13 times.
13 times, okay. So what about you, Shangyi? Okay, good. So now we'll see that, okay, clearly there's a difference between, so the same program, but we compiled using different optimization flags, and there's a significant difference between the performance. So okay, so okay, there's a result on my computer is 14 times faster. So why is that? Here is a link that we can use for online to see the compilation result. So everybody just click on this link right now, and it will show you this online tool. It's called Compile Explorer. What it does is just to basically show you the assembly code it generates based on the compiler you use and the compiler flags you add here. So after you open up this web page, this type a very simple function here. So basically you type a function called function1. It adds the input by 3 and return the results. And in the main function, there's a loop here for a loop and execute this x. So increment x by 20 times and see and then return it. So you type all these functions in this web page and this view the assembly code it generates.
So do we copy the code from test 1 into this?
No, you don't need to copy the code because that is way too complicated. So here
Okay.
you just write a simpler code just to
Okay.
show the difference of the compiler results by while using different compile options.
Done.
Done. Okay. So you don't have to worry about all the detailed the command of the assembly code, but here so in this mem function here, you will just see that it actually puts a 0 into this some kind of register here. So basically it assigns 0 to x, and it will jump to this .l4. .l4. So L4 here is to see if there's this I increment above above 19 or not. So it's kind of to see if we can exit for the for loop. And inside this for loop is actually the L5. So it actually increment this x by 1. So that is some basic understanding of the assembly code it generates. So it's basically the machine code that you will have in your program. So then the second step is to see if we change it to O3, and then the compile results will be a significant different. See, you only see that the compiler decides to put the 20 into this register and then to actually return. So the difference is that if we add choose to use -0, it follows exactly according to your logic within your logic based on the source code you provide. However, if you choose -03, the compiler then will decide, hey, so if you want the optimization at the compile time, And it sees that, okay, so now basically what you want to do here is to increment this x by 20 and directly return the results. But you don't actually need to execute this for loop while running your program. You can just directly return 20 here. So so one of the compile optimization the compiler gives you is that it will perform the so-called compile time calculations. So it will calculate this x in the compile time and directly put this result to as a return value. So in this case, your code will be smaller and it will be run faster. So that is one of the reasons why we have this performance difference. Why we have this performance difference when we're choosing different compile options. Basically, the compiler in the release build mode, it optimize your code to perform many compile time calculations and and other optimizations such as branch predictions and vectorizations as well. So this is a very important concept for compiling. So when you are debugging your code to see if your code runs according to the logic you provide or not, you use debug to find out to figure out whether the logic has some errors or not. And we wish to compare the performance of the code. See if you're trying to compare your method with another method, then you wish to build your code in the release mode because it's a lot faster than the code generated in debug mode. So okay, so any questions so far about all the CMake and the build and also the compile time optimization?
I'm good.
Okay. Okay, so there's a group. Yeah, okay, this is a recap of what we just done. So same program. If you choose aggressive compile options, it will generate it will directly calculate the result for you and generate a very small code. While if you specify no optimization, then it will follow exactly the logic you provide in your source code. Okay, now the final thing is Azure Sanitizer. So create another source file in this SR directory called test2 and type the following in your so this program will be simpler. So just type all this stuff in your source file and then build and execute the source.